Hi, and welcome back to my channel. Today, we're going to be talking about a very powerful and very cool generative AI algorithm that's used for drug discovery and for polishing up and reconstructing old and dilapidated images and pictures, and also for reconstructing corrupted audio files. This algorithm is called VAE, or Variational Auto Encoders. I call it vaguely approximates everything. But what exactly is a VAE, and why are VAEs important, and how do we actually build a variational autoencoder using Python code? Keep watching these videos and soon you'll be a master of variational autoencoders. VAEs, or Variational Auto Encoders, are a powerful set of generative AI tool. They are actually artificial neural networks that generate new data that is similar to, but not identical to, the data that it was trained on. You can think of them as generative machines that dream up slight variations of the input data. If variational autoencoders, or vaguely approximates everything tool, can only create something that is slightly different from the input data, how is it that they are useful, and what value do they actually add? It turns out that creating something that's a little bit different from the training data is still pretty useful. For example, it's known that most drugs fall into families of similar looking drugs or similar looking molecules. So if you can create a drug molecule that is a little different from the existing drug molecules in the family, then this new drug molecule might actually turn out to be more efficient, more potent, and less toxic than the other drug molecules in that family. Another application of variational autoencoders, or VAEs, is to fix old and dilapidated digitized images like the one that you see on the screen. So variational autoencoder, what it does is it fills up all the missing pieces of the picture in the same style that the original picture was actually taken. Sometimes audio files get corrupt and you can see that some parts of the music are actually missing. Variational autoencoders can actually learn from the existing musical data and use that to fill up the pieces that are actually broken. So what exactly are variational autoencoders? Variational autoencoders are composed of three parts, and this is depicted in the picture on the top left. The first part is the encoder, the second part is the latent space, and the third one is the decoder. What does the encoder do? Well, the encoder compresses the image or the audio file or whatever data that you are starting with into a low dimensional space, and this low dimensional space is called the latent space. It's sometimes also called the bottleneck that we will see when we actually see the code that actually makes the variational autoencoder. What is the latent space in plain speak? Well, the latent space is made up of latent variables. Think of latent variables as metadata that describe the data. For example, instead of actually seeing the food, you are actually only able to taste it, and you can check its texture and also its flavor. That is the metadata around food. The next step, the decoder comes in and takes this metadata or this latent space and tries to reconstruct the original data. If it's an image, it tries to reconstruct the image. If it's an audio file, then it tries to reconstruct. This is a little bit like you are squeezing a lemon to make lemon juice, and instead of making lemonade with the lemon juice, you are trying to use the lemon juice to reconstruct the lemon, and as you can see, you are ending up with a mangled version of the lemon. And thank you, and in the next video, you're actually going to see how you can make your own variational autoencoder using Python code.